So, good morning to all the participants. So, today I'll be talking on virtual private networks. So, myself, Arunraj Kumar, working as Associate Professor in Computer Science Engineering Department, National Institute of Technology, Calicut. This is my email ID, park@nitc.ac.in. So, the outline of the talk for this session is planned this way. So I'll be giving a brief introduction to TCP/IP protocol stack and security goals. These two topics are important, or I should call it as the prerequisite to better understand the virtual private networks. So then on the virtual private networks, I'll be giving introduction, talking about the types of VPN and what are the components involved. There are two phases that is involved in setting up the virtual private networks. So I'll be discussing on those two phases. And in terms of commercial VPN, what are all the security and privacy issues, research problems that are involved in the VPN? And I'll be summarizing it. So, and one more thing, like if anyone has doubt in between or you wanted to ask some questions, please stop me in between and I'll be happy to clarify your doubt. These are the URLs. Some of the words which I'll be using in the forthcoming slides. So, what exactly is the data? Is the raw and unprocessed facts or figures. So these are called as the data. For example, you have a sensor. So the sensor device will actually generate the data. Right? So that information that is actually called as the data. Information is the result of analyzing and synthesizing data or processed data. So, for example, if you wanted to take, your students' mark records, right? All the students in different subjects, you have marks details. So this is something called as data. Suppose I wanted to have what is the overall class average. So that is the information that I'm trying to obtain from the raw data that I have from the students' details. This is the difference that we have to understand between the raw data and the information. Infiltrate is the term which is generally used from the hacker's perspective, like to gain an unauthorized access, basically backdoor entry to a system. So for that we call the term as infiltrate. Then we call the security, which is the act of safeguarding from the potential harm. Then privacy, the ability of individuals to keep personal information confidential. So we can understand the security and privacy is slightly different terms. Breach, which is actually a violation of security or privacy. So what are the rules that we are keeping? So there is a violation of policies or rules. That we call it as the breach. And the term cyber refers to digital or virtual world that includes computers, networks, all. And cyber security is
when you're like option, there's a link down to the link. Open
protection. There is some question. Is there a question? Right. So cybersecurity is the protection of digital assets from the attackers. So understanding these terms, we can just move forward. What is meant by computer networks? So as per the textbook definition, so you could see here introduction, computer networks. Group of interconnected nodes that exchange data and resources with each other, which means you require at least two devices when you wanted to call something as a network. So you require at least devices. So a group of interconnected nodes that exchange data and resources with each other, or otherwise we also call like a system that connects two or more computing nodes for transmitting or sharing information. So mainly the reason for the development of networks is resource sharing, because the resources are available in different geographical locations. So how do I access that particular resource which is totally in a different geographical location? So that's the reason what motivated to evolve into this computer networks. Okay. So what does mean by so we can call nodes as device, which is computer, laptop, routers, switches, many things we call it as the devices. So that's what we call it as the nodes. Again, the devices we divide based on the visibility. So they are classified under two types based on visibility. One is visible to everyone, and other one is limited visibility. So visible to everyone in the sense, for example, um, so there could be a system, there could be a system. So they can see the term visible. So visible to everyone, which is public network, and limited visibility, which is not visible to public network. So the examples that you can give for the first part, visible to everyone, is all the web servers. What are the web servers that we are able to access through a browser, which means it is in the public network. Anyone can access the websites anytime that they want. So limited visibility in the sense, there are some resources which is available only within the IT or only within some particular organization. So outside the organization, we are not supposed to access. So there is a limited visibility for the devices and there is a complete visibility for the devices. So that's we call it as the public network, and this is something called as private network, right? So visible to everyone, which is public, and limited visibility is something we call it as private. So what is the term virtual? So if I call virtual, it means that which is not physically existing but appear to exist physically. So there is no physical existence for that particular whatever the suffix that we are going to attach with the virtual, whether it's a virtual private network or virtual whatever the suffix that we wanted to attach. So physically there is no existence, but it makes us feel that that it exists physically. So that's what it means by virtual. So this is the introduction to the TCP/IP protocol stack. Now you could see there are two models here. One is the OSI basic reference model, which consists of 7 layers, and then we have another model called TCP/IP model, which is the which consists of 4 layers. So the functionalities, whatever is being discussed, this all the 7 layers is also happening here. The reason for merging some certain layers, we see here, the physical and data link is being merged together to network interface. So which means uh, the the functionalities, whatever it has been available, it has been merged to a network interface. So you will be having a unified interface across the different heterogeneous networks. So that's the advantage of merging the two different layers. So like this, you could see there are some protocols in each layer. The Ethernet, RS-232 UTP cables, IPv4, TCP, NFS, SQL compression, encryption protocols, and you could see all the application layer protocols. So these are all the protocols in the TCP/IP protocol stack. Right. So this is the basic reference model which has been used, and each layer there is a protocol data unit, which we call it as the bits and frames. For network interface layer, we generally call the protocol data unit to be bits and frames. And for the internet layer, we call this as a
packets. And for transport layer, we call this as segments. And for application layer, it's called as data. So for example, if in your browser, if you're typing in the application layer, right? So for example, this is your application layer. So in your browser, if you're typing www.google.com, so that is actually your data, right? So www.google.com is the data that you type in the application layer. So before it leaves your laptop, it has to go through all this layers, right? So for example, here, if you're typing it in transport layer, you have to attach the transport layer header, and in the internet layer, you have to attach the IP header, and then here MAC header, medium access control header, and then finally it will be transmitted in zeros and ones. So whatever the data that you have, it has to be passed down to all the layers, right? And then it has to leave the system, right? So you could see here it is basically a modular architecture being followed in the TCP/IP protocol stack. So it looks like a black box from the outside. So as a user, I'm not aware whether this exists or not. I just type the data um, in the application layer, and then I guess the response page, home page of the. I just get the home page of the particular website. Right? So I think there are some participants waiting. So maybe I'll just make one more person as a co-host. They can take care of admitting the participants. So I'm making admin as a co-host. So whoever is the admin, please take care of admitting the participants. Okay, thank you. So what I'm saying is, like, you could see here there are layers which is following a modular architecture, just like bricks. So each and everything is independent, and then what are the data that you have will be passed on to down this all these layers, and then it will be leave the system. Right? So this is from the perspective of the protocol stack. Okay. So any questions? So this is the data encapsulation part. You could see here, this is what I was saying. So data, which is in the application layer, and then you're attaching the header information, which is at the transport layer, which is TCP header. It may be a TCP or UDP. So here in this example, it is given as the TCP protocol. So the difference between them is TCP is connection oriented, and um, UDP is connectionless. Connection oriented, which is the TCP, and connectionless, which is the UDP. So these are the standard protocols in the transport layer. In addition to that, there are many protocols, SCTP and other, but these are the standard protocols generally when we call it in the transport layer. So this carries something around 20 bytes. So why we have a header for all this data? Because it provides some additional information to the data. So when in the receiver side, it is easy to fetch what exactly is the particular data. So you could see here connection oriented, which means we have to establish the connection between 2 points. For example, here there is an A. There is an A, and here there is a B. So now, before we start sending the data, we need to first establish the connection. So that's what is basically a connection oriented. So once we establish the connection and then get the acknowledgement, then we can start transferring the data. So that's what happens in the TCP. But in UDP, you don't need to establish the connection. You can directly send the data whenever you want it. Suppose you have a data, you send immediately on the link, so it will reach P. The advantage or the difference between these two is TCP, we can call it as the reliable. Because when we say connection oriented, which means we are trying to establish a road, right? There is a road that I'm trying to create for between them. And after I lay the road, then I start transferring the data, which means it will travel safely here. And then for every data, I get the acknowledgement back. So we call it as the reliable. Whereas in UDP, we don't lay the road. We just throw it, the data on the link, and then that goes there. But we will not even get the acknowledgement back. So with this, we call it as the not reliable. So when you have a data in the application layer, you have to attach the transport layer header, TCP or UDP, depending upon the application requirements. So some applications demand reliable connection. Some applications demand unreliable connection, which means they are okay if the data is lost. Not all the data, some portion of the data. So depending upon the application demand, the protocol will be chosen in this particular header. Similarly, you have an IP header and then you have a MAC layer header. So IP header tells the, I mean, basically here you will have the source IP address and the destination IP address. Source and the destination IP address. So so if I wanted to know where exactly this packet, this entire packet is going, I need to look into this IP header. So if I look into this IP header, I can easily tell you that the a packet has originated from this particular point and it is going to this particular point. So where it is coming from and where it is going will be visible in this two fields in the IP header. Right? So that plays the role of IP header. Then we have a frame header, IP header, TCP header, data, and frame footer. So this is something called as a trailer. So basically in the MAC layer, medium access control layer, it may be a wired networks or wireless networks. You'll be having a header and the MAC header and MAC layer, we call it this place. So you could see here, this is the encapsulating the data. So when you have a data in your system or in your laptop or in your device, it is not the data alone being sent to the destination from the source to destination. So A to B, the data alone is not being sent. Along with the data, you have having some additional information attached, which will help the packet to travel from one point to another point and reach the destination. So these headers will have some information, right? And this information will help us to take this data from one hop to another hop. Because in practical internet, if you see, this is the source A, and this is the source, destination B. Suppose you wanted to send A to B, there is an internet here, right? So which is actually a public internet, we call it. So inside this, there could be some at least some 6 to 8 routers in between before it reaches the destination. So all the 6 routers in between has to process this package. So only if we send the data, this router will not have this information. So router needs some additional information with respect to the data. That's why these headers are helpful when we are routing the data from one point to the another point. Right? So this portion we call it as the data encapsulation. So this with respect to the TCP/IP protocol stack. Right. So any questions or doubts so far? Okay, you can stop me if you are having any doubts. Okay, so let's see what are all the cyber users. What are the different categories of cyber users? So employees working in a branch office and wants to communicate or share the resources to the headquarters. So that's we call it as the one type of a cyber user, right? So employees working in branch office, it wants to communicate. And employees or students working or studying from home and wants to access the employer's universities or resources. Right, this is like work from home option. Like during the COVID time, all the IT or academic institutes, everyone was working from home and they were accessing the resources of their particular company or university, and then they are communicating the emails and everything. Similarly, here the employees or students working from home. So this is also same during the COVID time. Many students were studying from home and they were accessing the university's resources. And travelers, they access their personal emails or do banking transactions in public Wi-Fi access points. So this we already experienced. Like when you travel in airport, there'll be a spot like public users, right? So public users, public Wi-Fi spots. Even in train stations, hotels, wherever you go, all these are open Wi-Fi uh, access points are there. Right? So when you want internet, you just connect to these open access points or open Wi-Fi access points, and then you get your details. Or you're connected to the internet. And also another category where the students try to access the restricted sites bypassing the university firewall. So if the university says students are not allowed to access the torrent, people will try to bypass the firewall and they try to download the movies from the torrents and all. So these are all the different types of cyber users. So I hope at least, all of you would have been fitting into any one of this category or multiple categories. If anyone is not fitting, just let me know in any of these categories. Right. So any questions? Okay, good. So then we'll just move on. So what do you see common in all these categories? Can anyone just text me guys in the chat, or you can just turn your audio and speak? What do you see common in all these categories? There are different users that we are talking about, cyber users. What do you see common in all these categories? Do you see anything common in all the four categories? Anyone? Yeah, can you speak a little louder because your voice is a little feeble, so I am not able to hear it properly. I'll just increase the speaker sound. So yeah, what do you see common in all these categories? Anyone in the chat? Access control. Okay. Anything else is common? Access controlled. Okay, access controlled. Right. Anything else in common? Anything else in common that you find in all these categories? Okay, so let's see what are all common. We could see one is the physical distance, because everyone is not trying to access a local device. They are trying to access something which is many kilometers away from them, right? Many miles away from them. One is physical distance, a separation. So the distance between the source and the destination is very high, right? So one may be in US, one may be in Australia, one may be in India, one may be in another place. So the physical distance makes something common here in all the four categories, right? And second thing that you see common is all are communicating a sensitive or private or critical data through the public infrastructure networks, right? So the public infrastructure networks is because you could see again, I'm going back to the same diagram. You can just see here. This is the pin. So this is the source A, right? And if you wanted to access B, you are actually going through multiple routers. And where these routers are there, you're not knowing it. So this is something we call it as the internet, From A to B, you are actually traveling through a public infrastructure networks. That is, we call it as the internet, right? So all they are trying to communicate, when you're doing a banking transaction, it goes via this. When you're doing some email checking, it goes via this. So everything is through something called as a public infrastructure network. So these two things are common with respect to all the four categories, right? Right. So what is actually required is you could see here, then definitely as per this diagram, you could see here. So because we are traveling or we are accessing or sending the data, suppose I have a data here from A and I wanted to send it to B, I am little reluctant to send this data in a public infrastructure networks, right? Which means the data may be a sensitive or it may be critical or it may be a private or something confidential I have, which I don't want to share it in this public infrastructure networks because it's why we don't want to send it because we call this as unreliable because the network is not reliable. So I am afraid to send the data to the public networks. There comes the need of virtual private in public. So how do I do in this public infrastructure networks? How can I establish something called as a virtual private? Not exactly private, but virtual private. You can see the difference here. So different color. Yeah. So here, which means now I'm trying to establish a tunnel in between this. Right. So though it is a public, but I wanted to put something called as a tunnel between this A and B. Then whatever the data that I have, I'm guaranteed that I'm sending the sensitive or private data in the public infrastructure networks. If we have the tunnel. If you don't have the tunnel, I'm afraid to send. If I have a tunnel, then I'm confident that this data is not seen by anyone. So this creation of tunnel, we call it as the virtual private network in a public infrastructure networks. Right? So we are trying to create a virtual private network in a public infrastructure networks so that the communication between the A and B is completely secure and private. Security and privacy is both achieved when you establish a tunnel between this A and B. So now we understood what is the need for a virtual private network in a public infrastructure networks, especially between the communication of two entities. All right, so far, any questions, any doubts? Or at least somebody can say yes or no, or I can. All right, so no questions. All right, so we'll just move to the next slide. So the session outcomes will be the participants will comprehend the concepts of security and IPsec VPN and will gain knowledge in setting up and managing secure communication channels over public networks, which is essential for remote work, inter-office communication, etc. And will gain skills in protecting the data at network layer. So we talked about some few layers: network layer, transport layer, application layer and all. So this VPN helps us to protect the data at the network layer, right? So how we are trying to protect the data at the network layer. So that's what is going to be our session. So initially we'll be having some basic introduction of security goals. So these are the goals of security. So I just quickly go through it as it's essential and prerequisite for understanding the VPN. So confidentiality is the data that is to be kept secret, not to be revealed to anyone. It should be kept secret. And integrity is the data that cannot be modified in transit. So yeah, it's explanation here. So data that cannot be modified in transit. Suppose you have a message. Suppose there is an A node and there is a B node and they have a message, right? So the same message should reach the B. Somebody in between should not able to modify the message, right? If you modify the message, then the integrity goal is not achieved. So the data that should not be modified in transit. So somebody in the man-in-the-middle attack should not be able to perform. Even if you perform, you should be able to find at the receiver end. If you're not able to find it, or if you're allowing someone to modify, which means your integrity goal is not achieved. And availability is from the perspective of servers availability or data availability, which should be available 24 cross 7. And authentication is who signs the data. So authentication, we have passwords, biometrics, tokens, all these things are examples for the authentication. And non-repudiation is something you do now and then you're denying later. So that should not happen in case of non-repudiation. So you do now and cannot deny the action later, whatever you have done. Suppose I sent a message, A has sent a message to B, and B says it's a fraudulent message, then A should not say, no, I have not sent the message. So you should not deny, A should not deny that I have not sent the message. So there must be a mechanism to verify the authenticity of this particular message. So that's basically, again, it's both are almost same, which is actually authentication is required. So these are the goals of security here. So let's get into some few questions. So security goals attack. This is the normal flow between a host A and host B. Suppose if there is an interruption between the host A and host B, which goal is compromised? Can anyone just type it in the chat or say by turning on your microphone? You see, first picture is something a normal flow. Both. What do you mean by both? What kind of goal is compromised? Which security goal? Because I was talking about some, you could see here, 5 goals. So among these 5 goals of security, which goal is compromised? This is a normal flow between host A and host B. And you could see there is something called as interruption. So which is the, what kind of an attack they are performing and which goal is compromised? It's actually interruption. So what kind of goal should be compromised? Any answers? Let me just see the chat. Okay, confidentiality. Any other answers? So it is an attack on availability, right? Because you could see it's a normal traffic, network traffic flow. Flow means it's a group of packets that are exchanged between host A and host B. Now somebody is stopping this particular communication between A and B. So basically is trying to deny the service. So denial of service is actually an attack on availability goal. All right, so then there is another attack. So somebody is trying to intercept the particular uh, data that is going on. Suppose A and B are communicating and he is something called as, so A and B are communicating, right? So there are some data which is flowing between A and B. And he is an attacker who is trying to do some kind of an interception on the traffic that is communicated between A and B. So what kind of a goal is compromised here? Any answers? Integrity? Okay. Any other answers? So what kind of a goal is compromised here? So it is an interception, right? So when it is interception, you cannot call integrity goal to be compromised because you're only doing a passive eavesdropping. So you're only sniffing the data and then you're trying to uh, not disturb the traffic between A and B. The A and B traffic is not disturbed. You're only trying to intercept the data, which means you're trying to sniff the data or passively monitoring the data. So what happens here is, in this case, the confidentiality goal is compromised. Right? And suppose A is sending a data and that has been modified by the attacker in between and then sending the data to the destination. So what kind of a goal is compromised here? So what goal is compromised here? So here there is a modification attack that is happening. So attack on which goal? Integrity. Okay, good. So there is an attack on integrity. You could see here. Okay. So there is also two forms of masquerading which you call it as the spoofing, sending message in someone's name, and delegation is authorizing someone on his absence. So both are the two different forms of masquerading. So one is example is, for example, if a teacher is taking an attendance and they call someone Raman or Rajesh's name, but the person is absent, but somebody is giving a proxy. So that we call it as the spoofing, sending message in someone's name. And delegation is, suppose HOD is on leave today, so he may authorize somebody or some other faculty to be HOD in charge. So delegation is something legal and spoofing is something illegal one. Right? So most of the attacks that you see, what are the attacks that you're seeing, I mean, reading it in the maxims, all are falling into the category called spoofing. So mostly it is illegitimate attacks. And this is something legitimate one. So where he is authorized to do this. So, okay. So one more goal. Okay. So host A has not sent anything, but host B is receiving a data that is sent in the name of host A. So attacker is able to send a message in the name of A to B. So B believes that, okay, the message has come from A. But actually the message has not come from A, it has come from an attacker. He just spoofs the name of A and then crafts the message and fabricates the message and sends it to the host B. So in such case, what goal has been compromised? So which security goal has been compromised in this case? Any answers in the chat or microphone? Okay. Availability is the goal. Okay, exactly. Non-repudiation. Okay, good. It's not non-repudiation or availability. You could see here what is basically very good. So authenticity. So you could see here the B doesn't have a mechanism to verify whether the message has come from A or attacker. Because B believes that the message has come from A, which means it fails to authenticate the message. Right? So he doesn't know who has sent the message. So he believes whatever been sent. So it's basically attack on authentication. Right? So authentication is another. Yes. All right. So when you go back to the security goals, all these 5 goals are important when we talk about the algorithm. So if you take any security textbook, all these textbooks talk about these algorithms. All the goals one by one. So where security is required. So for example, if this is a nuclear plant, and you know that in the nuclear plant, there'll be many sensors being deployed in different regions, right? And obviously, the administrator will not sit inside the nuclear reactor. They will be somewhere in the town, which will be some quite at least miles away from this particular nuclear reactor region. And they'll be monitoring all the other sectors because here inside this, there'll be multiple sectors. Each sector has to be monitored. And then they have to monitor the pressure, temperature, the airflow, everything they need to monitor. So this sensors information is actually sent in the public infrastructure. So if the question is like where exactly the security is required, so is it required here in the A region, or is it required in the intermediate region, or it is required in the B region? The answer is it requires in all the 3 regions. So from the start source to the destination, everywhere the security is required. Only then whatever the data that you've been generated by this sensor will be able to reach the destination securely and safely. So is a message generated seen only by B? It means the message is generated by A, and if it is seen only by B, then if the answer is yes, then we are achieving the goal called confidentiality. If the message generated was the same message received by B, whatever the message was generated is the same message that has been received in the B. Next question that we need to ask is the message really generated by A? Which means anyone has spoofed the message or it is really generated by A. What if A lies that the message was not generated by A? So if you answer all these questions, and then you could see all the goals are achieved. So here, these questions are common not only from nuclear reactor to the monitoring station. It is applicable to any source and any destination because and the intermediate places. Right. So anyway, from source to destination, these questions are to be asked where the security is required. Right? And we need to ensure all this goes. And of course, in VPN, we are trying to achieve all these goals in the network layer. We'll see that how we are achieving those goals. All right, so one question. So Raman arrives to a winter school workshop. At the reception desk, after announcing his name as Rajesh, he receives Rajesh's badge. So he wears it throughout the workshop. So can you answer the question? So which security goal is compromised at the reception desk? So can anyone answer the question here? Or anyone have a question before answering this? Do you have any questions? So we understood now what is the need for virtual private network and what are all the goals of security, right? So up to this, any doubts or any questions you have? Okay, yeah. Which security goal is compromised at the reception desk? Identity. So identity means which goal? Because we are talking about confidentiality, integrity. All right, authentication. Very good. Anything else? Any other answers? So which security goal is compromised here? It's basically authentication because in the reception desk, they failed to verify the asking their ID card or Aadhaar card to check whether he's really Raman or in the name of Raman, somebody has entered as, I mean, he's really Rajesh or in the name of Rajesh, somebody has entered. So that type of verification is not being done in the reception desk. So authentication goal is compromised at the reception desk. Good. So yeah, next. So workshop committee did not verify the identity and attack on authentication. So hope you answered. So very good. So in security, there are two things that we talk about. One is unconditional security and second is computational security. So it is also an interview question. So anywhere they go, what are the main requirements they call or what is basically requirement in the security? So one is unconditional, other one is computational. So unconditional means whatever the power that you have, computer power you have, whether it's a quantum computer or it's a very powerful server in the world, whatever you have, still the algorithm that you develop cannot be broken. Then you call it as an unconditional security. So question comes is, do we have such algorithm in practice or in real time or in theoretical manner? Do we have anything right now? Right now, we don't have anything in practical to say that this is the strongest algorithm. And this cannot be broken even with a quantum computer or even with any high power computer or supercomputers or cluster of computers. So this is something challenging here to provide unconditional security in the security research area. So what generally all this research and algorithms that we have right now is based on the second part, which is actually a computational security. So given limited computing resources, I can guarantee that the cipher cannot be broken. Or if you can break, it will take at least millions of years to break the cipher. By that time, this information, whatever you have, will not be completely valid. Okay. So all the algorithms are focused towards the computational security perspective. Right? So during a world war, actually there was something called one-time pad. So that is something which we can call it as an example for unconditional security, but now we are not currently using it. So right now, there is no such algorithms that we can come under this category. So we are all working on the algorithms. What are the algorithms that we are studying in security will come under this category called computational security. Right? So yeah. So if you look at the security goals and the techniques, so for confidentiality, to achieve the goal called confidentiality, we have to use algorithm called encryption algorithms. There are many encryption algorithms, DES, AES, triple DES, many encryption algorithms are there. So encryption means you have a message, right? And then you just keep it inside a box and then lock it using a key, right? So this now not seen by anybody. Only the person who has the key can open this lock and see the particular message. For others, it will be looking like a black box. They will not be able to know what is inside the box. Only the person who has the key can open and send it. That's what we call it as the encryption. So all the encryption algorithms is basically satisfies the goal called confidentiality. And to achieve the goal called integrity, we have to use algorithm called hashing. Right? It's similar to databases where you studied hashing. So similar way here also. It's a one-way function. One-way function we can call hashing map function. So given a random text, it will generate a fixed digest value. So it will be like this. So given a message, just write it here. Yeah, given a message M, it's a one-way function. So given a message M, it generates hash of M. So which means this M can be of variable, any text, any size. It can be a 10 bits, 14 bits, 100 bits, 1000 bits, any bits. But this will be something called as a fixed value. So this will be always as a fixed value. So given a message, it generates a hash of message. But given a hash of message, you cannot go back computing message. So because that is why we call it as a one-way function. The one-way function in the sense, given a message, you're able to generate the hash, but given a hash, you're not able to generate the message back. Whereas in encryption, it's different. Given a plain text, you're able to generate a ciphertext, but given a ciphertext, you will also be able to generate a plain text. Because for both, you'll be having the key. It can be a symmetric encryption or it can be a asymmetric encryption. In symmetric encryption, you'll be using both of them same keys. In asymmetric encryption, you'll be having two different keys. Each one will have two different keys. But I'm not covering it now. Let's understand that basically to achieve the confidentiality goal, we'll be working on the encryption algorithms. To achieve the goal integrity, hashing. Similarly, to achieve the goal availability, we'll be using load balancing, redundancy, and disaster recovery. For authentication, we're using the technique called digital signature. So digital signature and message authentication code. So these are the two very popular techniques. Even now it is used everywhere, including our browser clients. You will find that signatures are used. Similarly, multiple factors, biometrics, passwords, everyone is aware of. The non-repudiation, again, a digital signature. Right? So for achieving all these 5 goals, there are techniques available. These are the standard techniques that are available, and we are using it even today. All right. So any questions so far? Any doubts or questions so far? If you have any question, you can just type it in the chat message or for listening to the next part. There was a question I could not see. Let's get introduced to the VPN now. So the definition of VPN is a framework that consists of multiple remote peers transmitting private data securely to one another over a public infrastructure such as internet. So this is what I told initially. Like when A and B wants to communicate over a public infrastructure networks, right? They wanted to create something called as a tunnel, right? So that the data or the sensitive or private data, they can securely communicate between A and B, right? So this is the definition too. So it's an extension of a private network. It encompasses links across public network. So the advantage is it permits network to extend beyond their local topologies. And the model that we follow here is the hub and spoke model. You can see here the hub and spoke model. So this is the central point, and if anyone wants to talk to any other person, they come here and then they go here. They come here and then they go here. So the request comes here and then goes to the destination. So the request comes here and goes to the destination. The request comes here, goes. So it radiates inward and outward from inside the. So this follows basically hub and spoke topology. In other words, looks like a star topology. All right. So we are trying to provide security at network layer. Okay. So which network layer protocol? By using a protocol called IPsec. Okay. So we are going to use the protocol called IPsec framework to provide security at the network layer. So which means we were using data, TCP header, and IP header. Now, in addition to that, we also need to have something called as IPsec header. So that this is actually achieving the security at the network layer. So we also require TCP, we also require IP. In addition to that, we require one more protocol called IPsec to provide security at the network layer. And what goals we are ensuring here? Confidentiality, integrity, and peer-to-peer authentication and data origin authentication. These are the goals that are ensured or achieved using this VPN. And to achieve the security goals, there are two phases in VPN, and that's what we're going to see now. One phase is key management tunnel, or we call it as the internet key exchange, or also we call ISACAM. We also call something called as, some textbooks you can find the term. Okay. So one is we call it as the ISACAM. ISAAMP, which is actually Internet Security Association Key Management Protocol. So either they call IKE version 1, version 2, or they also call it as the Internet Security Association Key Management Protocol. So this is what happens in the phase 1 of the IPsec framework. And next phase is data management tunnel, which is your IP security protocol. So in the initial phase, we'll only exchange the keys and we'll only talk about the algorithms, what we are going to exchange and all, what technique we are going to use and everything. And in the second phase, the actual data management plane works into this picture. So which is actually in the IPsec protocol, which comes in the picture. Okay, so VPN types. So we were talking about these 4 cyber users category: employees, travelers, students, right? So when you look at this, all these 4 categories, I've also classified the VPN based on this. Suppose a employee working in branch office and wants to communicate or share the resource to the headquarters. So for example, a Cisco employee in Bangalore wants to communicate. So this is a Cisco office, we'll say A in Bangalore, and this is something is in Chennai. This is in Bangalore. So a Cisco office, an employee in Cisco office A wants to communicate to an employee in Cisco office B, then they have to use a VPN type called site-to-site tunnel, because this is something called as headquarters, or it's a branch office. This is also a branch office. So when they wanted to communicate, they have to communicate through public network, internet, of course, but still they need to create something called as a virtual private tunnel that needs to be created in the public network to have a secure communication. So this type of a communication, we call it as the site-to-site PPM. And another type is employees or students working from home. where they'll be not working in office, branch office. They'll be working from home and they'll be having their own mobile data or hotspot to connect to the university resource. So that type we call it as the client to site VPN. And whenever you try to access the internet in public hotspots, right? Many travelers they try to use something called as VPN client because they are not um, finding it safe to access the public networks. So they are not interested to leak their personal information or sensitive information. So therefore, they try to download the VPN clients and then they try to access the any websites that they wanted to access, which means they feel themselves that they are safe. So that's how the travelers mostly they use. And okay, there is also survey like saying like how many VPN users. There are many millions of VPN users are there across the globe, especially those who wanted to access the public Wi-Fi hotspots. And students accessing the restricted sites bypassing the university firewall. So this is also an example for commercial VPN. So basically the students, they download the uh, commercial VPN softwares, right, that are open VPNs, and then also there are many commercially available. So they try to download that by paying money or free or trial versions are there. So using that, they try to hide from the university firewall and then they try to access the blocked sites. So this is also possible in the commercial VPN. So there are three types. One is site to site, client to site, and commercial VPN. So these are all the three types of VPN that we're using. So question is commercial VPN safe? So what is your answer? So anyone is using commercial VPN? Anyone is downloading their VPN clients and then they're trying to access the websites? Just say yes or no in the and if you're using it, you can just say whether it's safe or not. How do you feel? Unsafe. Unsafe. Okay. It's not safe. Yes, it's not safe. Okay. All right. So is commercial VPN safe? It's not safe. Good. Good. So the answer is it is not safe. Okay. So you could see here some headlines that I'm trying to insist. So because you could see, you could think that you are hiding the farm and we are hiding uh, from the government or from the other university firewall policies. But the VPN's commercial clients, they actually try to read your information. So there is actually a rules that are there in all our DPDP bill, which we call Digital National Data Protection Bill that is passed in Lok Sabha. So you could see that to protect individual privacy from breaches by company collecting personal data. So in 3rd August, they also launched this because you would have noticed in some of the headlines saying that some government officials were tapped, their messages were tapped or their phone connections were tapped and all this. So intercepting a telephone of an individual without any intimation infringes right to privacy of an individual. This is Article 21 of the Indian Constitution. So no one is allowed to intercept, monitor, or decrypt your private, your information, whatever you're communicating through internet, except, except the authorized entities like Intelligence Bureau, CBI, NCB, ED, National Intelligence Agency. So these are all the authorized entities, those who are able to monitor or sensitize the data because they are doing it for the protection of the human, for the people in, for the Indian people or Indian citizens in the India. Right? So what are the components of VPN? So we are saying that virtual private tunnel. So it consists of multiple sessions. So each session is specific to one particular user. Right? So it is like this. So if you draw a tunnel, so for example, this is my A and this is my B. I'm creating a tunnel here. So inside the tunnel, there could be multiple sessions. This inside the tunnel, there could be multiple sessions. This means, so this is something like Cisco Office A, Cisco Office B, So inside Cisco Office A, there could be multiple employees. So everyone will try to create multiple sessions inside one tunnel, and then they try to communicate to it. So one specific portion of a tunnel that is pertinent to one's user A and one user B, we call it as the session. And collection of all the sessions together is called as the tunnel. And what are the devices that we use here? Basically, in the Cisco Office, there will be an endpoint router. And here also, there will be an endpoint router. So this endpoint router to endpoint router, it will be a VPN configured. We need to configure the VPN here. VPN configuration should be done here. These two endpoints must be VPN configured. And then all the employees of the Cisco Office A can talk through this endpoint and communicate through the to the employees in the B or to access the resources in B. So this is how it happens. So multiple sessions are created inside a tunnel. Phase one, it's a key management tunnel, or we call it as the peer authentication. So here it means this A and B, I mean not A and B, this A dash. So let us call this router VPN as A dash, this B dash. So in phase one, this A dash and B dash, they try to do some kind of a exchange their keys. You see what are all the things that they are doing it now. Key negotiation will be there. Key renegotiation will be there. Exchange of control messages, and then security associations. So all this four happens in the key management tunnel. So what kind of a key that we are going to use for the data communication? Because there is a next phase called data management. So in this phase itself, we are going to decide what is the key that we are going to use. And once we decided the key, the same key will be used in the next phase, all the algorithms. Also in this phase one, we are also creating the security association. We'll see that in the next slide, what is mean by security association. So security association is important part because here where we are talking, we'll be exchanging many parameters between the A dash and B dash, between those two endpoints. So what is the algorithm that supports? What is the hashing algorithm? What is the encryption algorithm? What is the authentication technique? What is the message authentication technique? So all these questions will be asked between two endpoints, and then they'll come to a conclusion. Okay, let us use triple DS algorithm for confidentiality. Let us use SHA-1 has a hashing algorithm for integrity. So like this, they'll come to a conclusion in this phase one. So they'll have a negotiation. These are the things that I support, and these are the things that I support. And let us come to a conclusion what we are going to use it in the data management tunnel. So both agrees, then they'll be following the same protocol and the same key, and then they'll be using the starting the communication. So everything happens in this phase one. Basically, it's a negotiation and finalizing the algorithms to be used in the next phase. So in phase two, what we are going to do is there are again two types of IPsec because in phase one it is IKE ISA camp, I called it. Phase one is ISA camp, ISA KMP, which is Internet Security Association Key Management Protocol. In phase two, we call it as the IPsec. So IPsec framework. In IPsec, we have two protocols. One is AH, the other one is ESP. So there are two protocols that we have, AH and ESP, and there are two modes of operation in each protocol. So in AH also we have transport mode and tunnel mode and tunnel mode. And in ESP also we have transport mode and tunnel mode. So these two protocols are used in the data management tunnel. So in the transport mode, it protects only the data, which is actually your payload. Only the payload portion is actually protected. So payload in the sense, as I go back to the same slide, this is data. So data will be attached with the TCP header and then will be attached with the IP header. So because we are now protecting the IP header at the network layer, or protecting the security at the network layer, right? So for us, this is seen as payload. This is seen as payload. So here tunnel protects only the data. Data means it's not only this data, it's both TCP and data. It protects the payload. And tunnel protects both the data and the identities of the endpoint. So in transport mode, they protect this TCP and data. In tunnel mode, protect the IP and TCP and data all together. That's the difference between your transport and tunnel mode. In transport mode, you protect only the TCP and data. In tunnel mode, you protect even the TCP, IP, and data, which means if anyone wants to see the, if anyone has an access to the packet in the transit mode, then he will not be able to know what is the source IP address and destination IP address. Who is talking to whom will not be known because this itself will be completely hidden. Right? So that is how they do it in the tunnel mode. So tunnel gives a complete security. Even the identities of the endpoints will not be known. The secrecy will be. Okay. So for any questions or doubts? For any questions? So this is an authentication header protocol. As I said, this is a payload which is including TCP header plus data and some additional padding zeros. Then between IP header and payload, you will be having an additional header called AH header, which is your authentication header protocol. So this protocol will be, this header information will be included. And this header information, you could see here, it got next header, payload length, and then security parameters index, sequence number, authentication data. So all these are all the fields in the AH header. So this consisting of 1, 2, 3, 4 into 32 bits, which is actually a, so each consisting of 32 bits. So 4 into 32 bits, that much is the size of this particular AH header. So then you have, so data cannot be modified in transit. So using this AH header, what it guarantees is data cannot be modified in transit and ensures that the message comes from the original sender. So which means authentication goal is also achieved. Using the authentication, definitely it is achieved because we are able to ensure that the message comes from the original sender. Similarly here, another protocol called ESP, encapsulating security payload protocol. So which is, you see the same thing, instead of AH header, we are also having something called as ESP header and trailer. So this is something called to provide integrity to the message. So for achieving the message integrity, we're using a hashed message authentication code. We're using a hashing algorithm here. And then we are also using an encryption here. So hashing and encryption together, we call it as the hashed message authentication algorithm. So generally, this both is used here as in the trailer end. So ESP header, again here also you can see that it is consisting of 1, 2, 3, 4, 4 into 32 bits. Instead of authentication data here in the last field, here it is sent as a initialization vector because it also uses the cipher block chaining. So in cipher block chaining, you require this initialization vector. Therefore, we are having this. So the ESP in transport mode, you could see here, as I said earlier, what is encrypted, you could see TCP header, payload, all are encrypted in transport mode, right? So TCP header and payload is encrypted, but still IP header is not encrypted, which means in transport mode, even in transport mode or tunnel mode, you'll be creating a tunnel. But in transport mode, the IP header information is not hidden, which means confidentiality is not provided in the sender perspective. Now we will be able to know who is the sender and who is the receiver in this case. Whereas in the ESP tunnel mode, we will not know who is the header, who is the sender and who is the receiver because actual IP header is this, and this is completely encrypted here. So when this information is completely encrypted, then the dummy IP header which is created in the endpoint is just attached only to route the packets. So the actual sender and receiver information is completely hidden in the tunnel mode. Whereas in the transport mode, the actual sender and receiver information is not hidden, right? But authentication perspective, you could see completely they have an authentication on this, which means message authentication including. So any change in the message, it can be easily found because they're using the hashing technique. Okay, so any questions so far? Any questions or all right. There are two databases that are maintained in the IPsec protocol. So when we call IPsec now, it is actually a ESP protocol nowadays because AH is something not used and very limited usage for AH authentication header. Because all the goals can be achieved by using the ESP protocol. So when you find IPsec VPN, many of the clients that they use, they are actually running behind this ESP protocol, encapsulated security payload protocol. So we have two databases maintained in this IPsec protocol, which is ESP. One is security policy database. The other one is security association database. So both are important when user wants to negotiate or when he wants to communicate to another user, especially in the VPN network. So let's look into this. What is mean by this databases? So in security policy database, the component that stores and manages the security policies used by the system on determining that how to process the incoming and outgoing packets, IP packets. So basically we have some kind of rules, policies saying that whether I should accept this packet or deny this packet or bypass or discard, all these things will be written as some kind of access control matrix in a rule set. So whether this destination IP address and this particular port, whether it is allowed inside my particular network. So all the rules is actually defined in the security policy database. So step is when an IP packet arrives at a device. Here device in the sense the router endpoint. The device in the sense it's an endpoint that has been used in the router. When an IP packet arrives at a device that uses IPsec, the SPD is consulted to determine how the packet should be processed because the security policy database holds all the set of rules and policies. So when a packet comes, we look into the destination IP header and source IP address, and then look for the match in the SPD. Is there any rule specific to this particular IP address written? If it is written, then we follow what is the action being defined for that particular rule. Right. So this is what is actually done in the security policies perspective. So next, the device matches the package attributes against the rules in the SPD to find the appropriate security policy. So that's what I said. So it matches the attributes based on the IP protocol and the source destination addresses. So if based on the match, the device decides whether to apply IPsec protection, which security association to use, and how to process the packet. If there is a match, then it decides whether to apply the ESP protocol or not. If not, it will just forward the normal packet. So which means it doesn't require the protection at this point. So next, security. What is meant by security association? So it is created using the process during phase one, which I already told you. So it uses UDP 500. So it consists of security parameters for authentication and encryption used by it. So security parameters in the sense, what kind of an algorithm for authentication, what kind of algorithm for encryption, what is the key, everything is actually described in the security association. So if you see, there will be three security associations required for one tunnel creation. The phase one security association, and in phase two, both for sender, one security association, and for receiver, one security association. So total three security associations will be required, which means three SAs will be required for one particular tunnel creation. So Security parameters. What are all the parameters that they are exchanging in the security association? One is security parameter index. This is something called as a unique value. Security parameter index is a unique value. And security protocol. Security protocol. So here, which protocol they're going to use, AH or ESP? And sequence number, which is actually 32-bit sequence number. So this will tell me to identify any, if that is suppose 0 to 2 power n minus 1. So that n is the number of bits in the sequence number. So after that, it will again wrap around and come back into this. And what is the encryption algorithm being used? Whether triple DES, CBC, and what is the encryption key? Authentication methods, other security attributes. What is the key lifetime? Because when we define the lifetime of the key, whatever we have found, so the key should not be used afterwards. So the mode of operation will be whether it's a tunnel mode or transport mode. If I wanted to have a complete protection, then I'll go for tunnel mode. If I don't wanted to have a complete protection, only the data protection, then I'll go for the transport mode. But depending upon the application requirements, I can decide what type of a mode of operation. So all this together is actually the parameters of the security association. So this is what will happen in the phase one. All this will be completely exchanged and they come to a conclusion saying that A and B will agree on using BS. A and B agreed on using this hashmag SHA-1. So they come to, and both of them, they agreed to use the ESP protocol. And SPA is something unique. So this will be useful when they wanted to create the SA. So this is a 32-bit identifier, the security parameter index, and used to identify the security association uniquely. So this SPA is the one which is used to identify the security association uniquely. So as I said, one tunnel requires 3 essays. So one during the phase 1 and other 2 during the phase 2. Between A to B, one essay, and B to A, another essay. So 3 essays, security associations are required. To identify this security association uniquely, you will be having something called as SPA. That is what is the security parameter index. So based on that, then they can easily, this information will be available in the database, security association database. It's a table basically. So based on this, we can easily map the incoming packet to the security association of the destination. So whatever based on the SPI, we can just map the incoming packet to the security association of the destination. Because the receiving side also, they maintain something called a security association database. So we are able to map the incoming packet based on the SPI and associate with the destination. In earlier days, this was also called as cookies. Now we are calling them in cookies, right? So this SPI is actually called as cookies in the earlier versions. So let's take an example here. Now Alice and Bob, they wanted to communicate each other, right? So what it does is it first contacts the security policy database, whether is there any security association or anything has been present over there. So then it looks like there is no security association created between Alice and Bob. So which clearly tells that Alice and Bob has not communicated before, right? So that is why there is no security association that is existing in the security association database. So therefore, we need to create an entry in the security association database. So it contacts the phase 1, which is internet key exchange, and then looks into the security policy database, and appropriately it creates an entry in the security association database. So it communicates with the Bob's security association database. Now they both will agree towards the phase 1, right? Then the security association of this Alice will actually send the SPI to the SAD. So based on the SPI, now SAD will have an entry because they already exchanged everything in the phase 1. So now it will actually send back. Okay, then it has to send back all this. Now if you look at this, again we need to create one more SPI entry from the Bob to Alice. Again, Bob also has to undergo same process similar to what has been done by Alice to Bob. So he has to again contact the IKV2 and then he has to create an entry and then again he has to generate the SPI and send it to SAP. This is what happens completely in the phase. After that, the data management tunnel, they can start exchanging their packets. Okay, so access control policies for VPN. Suppose I bought a new VPN router to my home. How do I ensure the security and integrity of the resource? Can anyone just tell me what kind of a questions that you can ask when a new VPN router to my home is being present? Can somebody tell me some questions? Suppose imagine that you are buying a new router to your home. So what kind of a questions or what kind of a policies you will try to set? Can you just think for a while? Respond all incoming traffic. Okay. Anything else? Is that sufficient? Is that, I mean, sorry, is that only, is that sufficient? Or any other questions you'd like? So let us see what kind of questions that we need to ask. So even if you buy a Wi-Fi access point, you need to ensure that who should access? That's the first question. Because we need to decide who should be accessing it. And what is the authentication mechanism to access? Who can connect to the device? So all these questions is important when we wanted to create the access control policies for VPN. If you buy a new VPN router, or even if you buy a normal home router, we need to decide all this, whether all the family members are going to access or only the parents are going to use it. Similarly, if the parents are going to use it, what kind of a mechanism we are going to have an access? So who can connect to the device and from which location they're allowed to access? Suppose you have something called as a server here in your university and you wanted to access that server resource from your home. And is that the particular location IP is allowed to access or not? So either we can create also a SSL VPN. There are two different ways of VPN we can create. One is IPsec VPN. That is what I'm trying to cover here. Also, remote access, we can also create the SSL VPN. So what timing is allowed? What ports or traffic to be allowed? Because if I don't implement, if I don't ask these questions, and if I don't implement the access control policies, then the VPNs are not safe. So it means that you are actually leaving a backdoor entry for the attackers to exploit your system. So that becomes a vulnerable point. Okay? So that's why these questions are important when we try to write the access control policies for VPN. It's not only for VPN, even for any security device, I mean, any resource that you would like to share to the outside world, we need to ask all these questions. So yeah, so also the logs. So who monitors and accesses the server? Because whoever is accessing the resources will be stored in the logs. So again, the logs access should not be given to a public because it leaks the confidential information or private information relevant to the security, university. Therefore, even we need to have privilege or access control privileges to decide who is going to access or monitor the server logs. So why VPN now? You'd understood like we are able to have enhanced security and privacy at the network layer and anonymous browsing because nobody knows who is watching the website except the VPN, commercial VPN providers. Even the ISPs are not aware if you're using a VPN client, the ISPs are not aware which site you're watching. So access to restricted content. Suppose in India, some of the websites are not or restricted. So what they try to do is they try to download a VPN client from Europe and then they try to access the restricted site because through Europe you're accessing the site that is restricted in India. So this is something called access to restricted content. So remote access and secure connection, then protection against surveillance. These are all important points that is required. I mean, why we require this VPN. So VPN actually provides this type of facilities. So does VPN providers track on which website that the users visit? So what is the answer from your side? Does VPN providers track on which website that the user visit? So what are the sites that you're watching? Are they tracking on? Are they tracking on what website a particular user is visiting? The VPN providers? Anyone? Yeah. Hello. Am I audible? Is anyone there? Am I connected to the network? Okay, okay. Thank you, thank you. Yeah, fine. Sometimes I feel like just talking to the wall. All right. So yeah, okay. Yeah. So the question is, does VPN providers track on which website the users visit? Do they do the track? Yes or no? Are they tracking? The answer is yes. The VPN providers are tracking the user website. Suppose, um, yes, correct, good. So providers. So one of the student has answered like saying the providers also have logs, so they are able to access. Correct, true. Because whatever the sites that you're visiting is stored in the VPN's logs, server logs. So using the server logs, they're able to find what time and what website you're watching. Everything will be evident from it, and they're easy to track. That is why when you are a VPN user, you will be seeing ads relevant to your search, right? So that's also there in the Google when you use it, but even in the VPN, you can find it out the ads on the left-hand side or right-hand side coming and popping up. That is because they are leaking your information. They are not only tracking, they are also selling your information. They are saying that Mr. XXXX is actually watching this particular website. So we have to sell for that information. They're getting some dollars. So they are not only stealing, they are stealing and selling. So stealing and selling is what happening in providers. So is there any way to secure from this? Yes, because request to DNS is not encrypted. Yeah, even you can see that because you are sending a UDP query. UDP query, the request is encrypted. Therefore, you are able to track also from the labs. Okay. Is there a solution for privacy from the ISPs or VPNs? So, question is, can we avoid? Can we avoid from this tracking? Is there a solution for privacy from the ISPs or VPNs? Because most of the users, uh, they actually are they wanted to have privacy, especially that they don't wanted to uh, see that they don't wanted to leak their private information to the outside world. So they're afraid of ISPs, also the VPN clients and everyone. Like whether they are selling their information or they're taking the information, putting there somewhere and all this. Do we have a solution for privacy from this ISPs or VPNs? Any answers? Do we have a solution for this? Yes, we have a solution. That solution is called, we can use a oblivious DNS server. Private VPN through the free tier on cloud providers or alternative internet protocols like I2P. Not exactly, because that can be done if you are using the logs, but still the VPN providers have access to it. The only possibility is the oblivious DNS server we need to use. So what is mean by oblivious DNS server? It is actually two times of encryption. So let me just give you an example. So suppose it is like, for example, you have a message. So this message is encrypted with K1 first, then it is encrypted with K2. So K2 is known only by VPN and K1 is known only by obvious DNS server. So double encryption will actually protect the message so that VPN server will not know what is the website they are trying to access. I mean, what are the websites the customers are trying to access. So this is one solution, like 2 times of encryption, which we can use it for privacy purpose. So VPN server will only decrypt and send it to the obvious DNS server. An obvious DNS server will only know uh, the actual message. So here it is most interesting part is this DNS server doesn't know the customer and the VPN server doesn't know the website that they are watching. Okay? So what website they are watching, the VPN server doesn't know. And obvious DNS server only knows the website where that they wanted to send the IP address back, right? But it doesn't know who is accessing the website. Right? So you could see it's double encryption actually protects privacy from these two persons. So this is how our banking transaction also happens. Like the supplier and the banking payment. So two double encryption is done so that the supplier doesn't know what is your card details and the bank doesn't know what is the product you're purchasing. Right? So that's how the type of a privacy which is given as a solution from the ISPs or VPNs. Okay, any questions? This is one example. So IP without site-to-site VPN, you could see this is how it happens generally. Suppose I have not established the VPN. I'll be communicating through a public infrastructure network. So this is my access point. So this is my access point, Cisco router in the Bangalore office. This is my access point at the Chennai office. If you don't have a VPN, then all the communication are seen through this internet point. So anyone who's in the internet will be able to read the information. So layer 3 and layer protocol, if the packet is captured, okay. So the question is, suppose if you're capturing using a Wireshark tool, so what will be the layer 3 and layer 4 protocol? Any answers? In your TCP/IP protocol stack, what will be the layer 3 and layer 4 protocol? If you're capturing a packet using a Wireshark, here, in this point. So layer 3 will be, any answers on the text box? This is without using VPN. So it's a normal case. So without using VPN, what will be your layer 3 protocol? IP, very good. Then what will be a layer 4 protocol? If I'm not using the VPN, it's a normal connection that I'm trying to use to talk to my branch office. So what could be the layer 4 protocol? It may be a TCP or UDP. Okay. I'm going back to the next slide. Now you could see, now we're using the site-to-site VPN, which means I created a tunnel between the two endpoints. So I've created a tunnel between two endpoints. So what will be the layer 3 and protocol if I capture using Wireshark? What will be now the protocol? Layer 3 and layer 4. Already the answer was there in some of the previous slides. Anyone can guess what will be the layer 3 protocol, what will be the layer 4? If I'm using a site-to-site VPN, IPsec protocol. Any answers? So layer 3 will be IP and layer 4 will be ESP. It will not be TCP. And this ESP will be identified by what? Security primary index, which is not a port number. It's not a port number. Right? It is a unique number for the security association. So that's the difference when we try to, that's the difference that we have when we try to capture a packet using a Wireshark after creating the tunnel. So you could see this is how it is. So these are the real world deployments where you could find this type of VPN, especially in the remote work enablement, secure transactions, telemedicine, global supply chain, secure communication, and point of sale systems. So research problems in VPN. So these are all the recent research issues that has been focused in VPN, like how to enhance the security of the VPN, because even VPN have the standard algorithms, but still there are some vulnerabilities existing. So how to enhance the security in VPN softwares and performance optimization. That is also one more important parameter because based on the bandwidth, throughput, and latency of the transmission link, how to optimize the performance, because you could see that some cryptographic algorithms are computationally very complex, very high computational complexity. So therefore, we need to have optimized performance in terms of the computational complexity. So that is one thing. Also, there is a research issue which is going on, and also like how to achieve 100% privacy and anonymity. So using the secret sharing schemes, there are some research going on in this VPN. Also in IoT and edge computing integration, um, to leverage the networking technologies. They are using this IoT and edge computing also with respect to the VPN. And multi-protocol support and interoperability, because at the higher layers, because it needs to provide a platform for the heterogeneous network. So higher layers, there could be many protocols. So how multi-protocol support can be provided, right? So from the layers. So you can see there is a data set which is publicly available. This is also used in many of the research papers published related to VPN. So even if you want, you can also download this standard data set and you can just go through the traces of the VPN traffic and you can apply for your research. Zero trust is one thing that the industry is moving towards. So initially we had something called as at least some portion of the place, we at least had something called as implicit trust. We will not trust entirely, at least some implicit trust we will have, depending that, okay, it is safe. But now from start to end, from source to destination, in any points, we will not have any trust, which means we will only verify, then we will trust. So it's completely a zero trust is the it's a term that every industry, especially in our security industry, is moving towards. So there's a traffic classification. So I'm getting in details. So port-based, packet-based, flow-based, and packet payload. This is again from the research perspective. So what kind of analysis that I can do? Either by capturing the port numbers, I can do some analysis, or by analyzing the packets, or by analyzing the sequence of packets or payload. So mostly you could see most of the research are focused in the packet analysis. You can also, they will also call it as a fingerprints. So they may have size of the packet as one feature or byte pattern. Like this, they may have multiple features. These all they call it as a fingerprint to detect whether this is a VPN traffic or a normal traffic. So to classify the traffic, whether it's a VPN traffic or not a normal traffic, they actually use this type of fingerprint. These are the network tools that are available. It's an all open source. You can also download and make use of it to generate the traffic and to capture the traffic and to generate the attack traffic and see uh, how the throughput analysis and loss of the packets happens. The VPN analysis is one which actually tests the VPN services of several VPN vendors. Suppose you are downloading a VPN client, you wanted to test, it's better to use the VPN analyzer. They'll test the VPN services, and then they'll give you some results on the several VPN vendors. So better to use this type of analyzers before using it. So this one example where I have used when I was working when I was doing PhD. So you could see here, this is actually based on the funded project, CDB SSC project funded by NTR or New Delhi. So I was working as a project associate here in this project in NIT Trichy. So you could see here, there are some 8 locations: IIT Madras, Anna University Chennai, Pondicherry University, NIT Trichy, Alagappa University, Madurai Kamaraj University, then Tyagaraja College, PSG College. All are in different locations. And we were all having something called as a VPN cloud. So this MPL is this multi-protocol label switching, which is, we call it as the layer 2.5 protocol. So using this VPN cloud, though we were in different geographical locations, we were able to access the resources of IITM, we were able to access the resources of Pondicherry University and everything. So this is something, an example, like where we had a practical experience of working with the VPN cloud. We used to develop the video monitoring softwares and everything. And yeah, so this is one real-time experience that I had. Okay, so not getting to this, I'm just skipping this. All right, so questions. Now, questions to the audience. Is NAT and VPN's purpose the same in hiding the private IP address to the outside world? So what is your answer? There is a term called NAT, which is Network Address Translator. Network Address, sorry. Network Address Translation. So there is a term called NAT, Network Address Translation, which translates, given a private address, it translates to a public address, right? So is NAT and VPN's purpose the same in hiding the private IP address to the outside world? Because in NAT also they hide the private IP address, and then it only shows the public IP address to the outside world, internet. So our internal organization, either VIT or NIT, is safe. Whatever the private IP address is not visible to the outside world. So that takes care of converting the private to public. And VPN also, if you see, it is also similar to it, but is it the same? That's the question. The purpose is the same. Almost it's the same, but if you look at here, in the VPN, we are also providing security, which is not provided by the network address translation. Still, they are aware of what is the IP address which is used here. But when I use VPN, they are not completely aware of who is the sender, who is the receiver, and everything. They can just protect it in the tunnel mode. So therefore, they are not the same in when they are hiding the private IP address to the outside world. Okay, next question. So is security association in IPsec VPN asymmetric or not? Any answers? Is security association in IPsec VPN asymmetric or not? Symmetric. Okay. One answer. Anyone saying symmetric? As I said, like there are during initial stage asymmetric. Okay. Actually, I said like there are 3 security associations created in the IPsec. So in the initial stage and in the uh, data management stage. Right? Data management stage, you could see it is not asymmetric. This is where the IPsec protocol comes into the picture. And this is ISA AMP. In the initial stage, it is symmetric. In the later stage, it is asymmetric because you require 2 SA for outgoing and for incoming, right? Because SA is only for one direction in the data management stage, in IPsec protocol. Whereas here it is for both directions. So 1 plus 1 plus 1. So here it is something called as asymmetric. So the question is IPsec VPN, which is here, not ISEC AMP. So it is actually asymmetric. So the answer is yes, the security association in IPsec VPN is asymmetric. Does IP header encrypted when a packet is encrypted in ESP tunnel mode? What is the answer? Is the IP header encrypted when a packet is encrypted in the ESP tunnel mode? In tunnel mode, is IP header encrypted or not? The actual IP header, not the dummy. Original IP header is encrypted. So, yes, the actual IP header is encrypted. So I'm just running out of time. So summarizing, so IPsec VPN is robust and widely used technology for creating a tunnel in public networks. It achieves the security goals like confidentiality, integrity, then authentication, which is peer-to-peer, as well as the data origin. And source and destination IP address are hidden from the address. So which means we don't have who is the sender and receiver information. And one more thing is this is something is based on the standard protocols like DDES, AES, and digital signatures. These are all some standard protocols which is used in IPsec VPN so that it ensures interoperability across different VPN vendors. And two types of VPN, one is site-to-site and remote access. So site-to-site, mostly it is IPsec VPN. Remote access, they can also use IPsec VPN, and sometimes they also use the TLS VPN. So even in remote access, we can use IPsec VPN. That ISAC AMP that I've talked about two phases, that is also can be used as a remote access VPN. So in remote access, TLS VPN also can be used. And commercial VPNs is basically a national cybersecurity threat. This is from the Indian perspective. So India is classifying this commercial VPNs as a national cybersecurity threat. To summarize, so there are almost across the globe, there are almost 2,500 VPN servers worldwide. And among that, I think some 1/3 of the servers are falsely claiming their locations, and then they are not genuine also. So it's little risky from the user perspective if they're trying to use any commercial VPNs, right? So you can use the VPN analyzer to test and then make use of it. But this is the the background information related to all this VPN softwares. Thank you. Any queries? Any queries here regard to the VPNs? You can type it in the chat window. Yeah, if you have any questions, you can just type it in chat or you can just ask my phone. Okay, no questions? All right.
Okay, this no questions. So I hope yesterday you had a practical oriented session from the Cisco team connecting the the VPN TLS aspects of network security. And today, yes, Dr. Arun, yeah. So today, Dr. Arunraj Kumar has given you the background networking concepts starting from the the TCP/IP protocol stack onwards. So now you will be able to better connect what was taught yesterday and day before yesterday and the topics that are covered by Dr. Arunraj Kumar today. So with this, I would like to thank Dr. Arunraj Kumar for taking the time. Though you are not here physically, perhaps because of the disturbance due to the cyclone. Otherwise, you would have been here and we would have had a full day session with the help of Dr. Arunraj Kumar. But anyway, nevertheless, we will grab the opportunity next time. Thanks, Dr. Arun.
Thank you, sir. Thank you very much. Thank you all the participants. All the best.